An automotive engineer ran the numbers on Mazda's 0W20 recommendation. A master technician with decades of engine teardowns under his belt pulled apart Skyactiv motors that followed that exact spec. What they both found, independently, through completely different methods, should be required reading for anyone driving a Mazda right now. Because here's the uncomfortable part. This isn't a fringe argument from people who distrust manufacturers. These are two people who generally defend modern oil science. People who have spent years pushing back against the just run thicker oil crowd. And they both came to the same place when they looked at what Mazda's official recommendation actually produces inside these specific engines under real driving conditions. So let's get into it. No filler. Mazda has quietly built one of the strongest reputations in the automotive world for obsessing over engineering details most other manufacturers wave through on a cost-benefit spreadsheet. The Skyactiv platform, their proprietary engine, transmission, and chassis architecture, is genuinely impressive work. The Skyactiv G naturally aspirated engines run some of the highest compression ratios of any production gasoline engine on the planet. The Skyactiv X is the first mass production gasoline engine to use spark-controlled compression ignition. These aren't conventional powertrains wearing a marketing badge. Mazda's engineers clearly care, which is exactly why the oil recommendation question matters so much. If any manufacturer should have this figured out, if any brand's factory spec should hold up under scrutiny, it's Mazda. The irony of this video is that we're not talking about a budget brand cutting corners. We're talking about a company that over-engineers their suspension geometry, but may have created a tension between fuel economy mandates and long-term engine durability that their owners were never told about. Now, before we get into the data, let's be precise about what we're actually examining here, because this matters. The sources being used in this analysis are not YouTube opinions. We're pulling from Blackstone Laboratories' used oil analysis data, independent third-party testing on samples submitted by real Mazda owners over years of accumulated submissions. And we're looking at Mazda Technical Service Bulletins, which are manufacturer-issued documents sent to dealerships when known issues emerge, and we're working from viscosity retention data collected at operating temperatures. Not just cold pour specifications on the back of an oil bottle, but how these oils actually behave inside a running engine at 230 degrees Fahrenheit after a 45-minute highway pull. That distinction is important. A lot of the confusion around oil specifications comes from people comparing cold pour specs and calling it a day. What happens to viscosity under sustained heat and mechanical shear is a different question entirely, and it's the question that actually matters for your engine. Here's where Mazda's situation becomes technically unique compared to most other brands. To understand why oil choice hits differently on a Skyactiv engine, you have to understand what these engines are actually doing. The Skyactiv G, the naturally aspirated 2.0 and 2.5 liter units found in the Mazda 3, CX-5, and CX-30, runs a compression ratio of 13.1 or 13.4.1 depending on the year. For context, most naturally aspirated gasoline engines run 10.1 to 11.1. That's not a minor difference. Higher compression extracts more energy from each combustion event, which is how Mazda gets strong fuel economy numbers from a naturally aspirated engine without forced induction. But high compression combined with direct injection creates a specific problem. Direct injection, where fuel is sprayed directly into the combustion chamber rather than mixing with air in the intake port, increases fuel dilution. Some unburned or partially burned fuel makes it past the rings and contaminates the oil. This happens on every direct injection engine to varying degrees. At Mazda's compression ratios, the combustion dynamics are running closer to the edge, and the consequences of oil degradation are proportionally more significant. Think about what oil dilution actually does. It lowers viscosity. It reduces the oil film's load-bearing capacity. Thinner oil film means metal surfaces that are designed to be separated by a few microns of pressurized fluid start coming closer together under load. That contact generates wear metals, iron, aluminum, copper, that show up in used oil analysis. And here's the thing. It doesn't cause a catastrophic failure overnight. It's slow, it's cumulative, it's exactly the kind of damage that doesn't show up until 140,000 or 160,000 miles when you're well past the warranty conversation. Now listen carefully, because this is where it gets uncomfortable for Mazda's official position. The Skyactiv X engine, Mazda's most technically sophisticated production engine, uses what they call spark-controlled compression ignition, SPCCI. The basic principle, under certain load and temperature conditions, the engine always ignites a rich fuel mixture near the spark plug, which generates a pressure wave that spontaneously ignites the lean mixture in the rest of the combustion chamber. This is essentially controlled auto-ignition, the same phenomenon that causes knock in conventional engines, but managed with extreme precision. The fuel efficiency gains are real. The engineering achievement is genuine. But SPCCI operation depends on precise combustion timing, and combustion timing in this engine is partly managed through oil pressure-fed variable valve timing systems. When oil viscosity changes through thermal degradation, fuel dilution, or shear breakdown, the hydraulic response of those systems changes too. Not dramatically, not immediately, but the margin for variance is narrower than in a conventional naturally aspirated engine. The SkyActiv X is arguably the most oil-sensitive engine Mazda currently produces, and Mazda's recommended viscosity for it is 0W to 20. Then there's the 2.5 turbo. The turbocharged 2.5, found in the higher trim CX-5, CX-50, CX-9, and Mazda 6, is a fundamentally different thermal environment. Turbochargers compress air before it enters the combustion chamber, which raises intake temperatures. The turbocharger itself reaches temperatures that can cook oil at the bearing journals if the flow and viscosity aren't adequate. Post-shutdown heat soak. What happens to the oil sitting in the turbo housing after you switch off a hot engine is a known stress point for thin viscosity grades. Mazda recommends 0W20 for the 2.5 turbo. And this is where the used oil analysis data starts raising questions. Blackstone Labs has processed thousands of oil samples from Mazda owners over multiple years. Their aggregate data on SkyActiv engines, specifically the 2.5T, shows viscosity shear down on 0W20 samples at standard drain intervals. What starts as a 0W20 oil, with a measured kinematic viscosity in the 8 to 8.5 Cst range at 100 C, can test in the 6.8 to 7.2 Cst range at the end of a 7,500 mile drain interval in turbocharged applications. To put that in plain terms, the oil is behaving more like a 0W16 by the time you drain it. The minimum specification for a 0W20 is 6.9 Cst at 100 degrees C. Some of those samples are brushing that floor. And this is important. Blackstone is not an advocacy organization. They don't have a stake in what viscosity you run. They test what you send them and report what the chemistry shows. When their aggregate data on a specific platform starts clustering near the lower viscosity limit at normal drain intervals, that's a signal worth taking seriously. The wear metal picture is more complicated, and this is where the two expert perspectives diverge slightly, and where that divergence is actually more useful to you than a clean consensus would be. The engineering perspective on this data is nuanced. Modern engine metallurgy and machining tolerances are dramatically better than they were 20 years ago. What would have been a problematic wear rate on a 1990s engine may be within acceptable engineering tolerance on a SkyActiv. The 0W20 spec was developed in collaboration with the actual engineering team that designed these engines, and there are sound theoretical reasons why a lower viscosity oil can actually be protective in a high compression, tight tolerance engine. Reduced pumping losses, faster flow to critical bearing surfaces, on cold start, better oil wedge formation at designed clearances. That argument has merit. It's not manufacturer propaganda. Modern engine design genuinely has changed what optimal oil viscosity looks like. But here's the view from inside the engines. Technicians who have torn down high-mileage SkyActiv engines, specifically 2.5L units from CX-5s, with 130,000 to 180,000 miles accumulated on factory spec oil, at factory recommended intervals, have documented a consistent pattern. Elevated varnish deposits on piston rings, above average wear scarring on cylinder walls compared to naturally aspirated SkyActiv G engines of similar mileage. Oil consumption rates trending upward from around 80,000 miles in a subset of 2.5T examples that stayed on 0W20 at 7,500 mile intervals. Neither observation invalidates the other. That's the honest position here. The engineering case for 0W20 in a SkyActiv is legitimate. The real-world teardown pattern in turbocharged applications suggests there's a subset of driving conditions, climates, and use cases where 0W20 at Mazda's standard interval may not be the optimal choice. Now, here's the piece that most people watching this video have never heard about. Mazda's European owner's manuals and service documentation for the same SkyActiv G and SkyActiv X engines, same displacement, same model year, sold in different markets. In some cases, specify 5W30 as a recommended viscosity alongside or instead of 0W20. European market conditions do include colder average winter temperatures than much of North America, which partially explains the W rating difference. But 5W30 versus 0W20 isn't just a cold start story. The high temperature viscosity of a 5W30 is meaningfully higher, 9.3 to 12.5 Cst at 100 degrees versus 6.9 to 9.3 Cst for a 0W20. Those ranges don't overlap at the extremes. Mazda recommends different viscosity grades for the same engine in different markets. That's not a conspiracy. Manufacturers do this based on regional temperature averages and fuel quality. But it does mean there is no single universally correct answer. And the question of whether 0W20 is optimal for your specific driving conditions in your specific climate deserves more than a one-line owner's manual recommendation. So where does this leave you? Here's the conditional breakdown. If you're driving a naturally aspirated SkyActiv G, the 2.0 or 2.5 in a non-turbo Mazda 3, CX-30 or standard CX-5, and you're doing mostly mixed or highway driving in a moderate climate, Mazda's 0W20 recommendation is defensible and likely fine at their standard intervals. The engineering case for it in this application is solid, the thermal stress is lower, and the used oil data on naturally aspirated SkyActiv G engines doesn't show the same shear down pattern as the turbo applications. If you're in that same naturally aspirated engine, but you're in a hot climate, sustained ambient temperatures above 95 degrees, significant stop-and-go driving, lots of short trips, consider tightening your drain interval rather than changing viscosity. Every 5,000 miles instead of 7,500. The data suggests this is more protective than switching grades without changing intervals. If you're in the SkyActiv X, Mazda's compression ignition gasoline engine, this is the application where the most conservative approach seems warranted. The evidence base is smaller because this engine is relatively new, but the technical characteristics suggest it benefits from fresh oil more than most. Short intervals on whatever grade Mazda specifies in your regional documentation. If you're in the 2.5 turbo, this is where the case for re-examining your spec is strongest. The evidence from used oil analysis and teardown data is most concentrated here. If you're beyond 80,000 miles, running in a hot climate, doing a lot of towing, or using extended drain intervals, consider discussing a move to July 30 with a trusted independent technician who can look at your specific engine's used oil analysis results. You can submit a sample to Blackstone or a similar lab for under $35 and have actual data on your specific engine within 2 weeks. That's far more useful than generalizing from aggregate data. Regardless of which SkyActiv you're running, pull your dipstick this week. You're looking for two things, level and color. If the oil is black and opaque at less than 4,000 miles from a change, fuel dilution or combustion blow-by is happening at a rate worth investigating. If the level has dropped more than a quarter quart between changes, oil consumption is beginning, and that's an early signal worth tracking before it becomes a bigger conversation. Check your owner's manual oil section against the European spec for your model year if you can find it. The comparison is genuinely instructive, not because the European spec is automatically correct for your situation, but because seeing that Mazda themselves recommend different grades in different contexts makes the whole question feel less like you're questioning authority and more like you're just doing the same exercise Mazda's own engineers already did. This is genuinely a case where two credible experts looking at real data landed in slightly different places, and both are worth hearing. The engineering perspective says modern 0W20 is more capable than people give it credit for, and that the tight tolerances of SkyActiv architecture actually benefit from it. The technician's perspective says what you find inside engines at 150,000 miles tells a story the spec sheet doesn't fully predict, and the pattern in the 2.5 turbo deserves attention. Both of those things can be true simultaneously. That's not a cop-out. That's an accurate description of where the evidence sits. What neither of them said is that everything is fine, and you don't need to think about this. If you're a Mazda owner, take the 5 minutes this week to pull that dipstick, check your interval, and look up whether your regional spec matches what Mazda recommends elsewhere. You've already got the information now to make an informed decision, rather than just trusting that the owner's manual covers every driving scenario you're going to encounter. Drop a comment with which SkyActiv you're running and what you've been using. I'm genuinely curious what's out there in the real world, because aggregate data only tells part of the story and individual experience adds a lot of texture. And if this made you rethink something you'd taken for granted, pass it along to a Mazda owner who hasn't had this conversation yet. Subscribe if you want to catch the follow-up where we go deeper on what used oil analysis actually looks like on high-mileage SkyActiv teardowns. The visual evidence from inside those engines is harder to argue with than any spec sheet.